Okay, so general equation of a circle with center at 0, 0. Who knows the equation? Yeah, Kaylin?
Like radius squared, basically.
Yeah, that's part of it, but the left side of the equation?
Y squared plus x squared
Equal.
R squared.
Okay, so usually we write the x squared first. X squared plus y squared equals r squared. Okay, this equation is when the origin is at 0, 0. So find the equation of a circle with center at 0, 0 and a radius of 6. So for this circle to have a radius of 6, 1, 2, 3, 4, 5, 6, so this has a radius of 6. Can someone give me another point on the circle? Yep.
0, 6.
0, 6. What about another point? What's another point on this? Yep.
6, 0.
Negative 6, 0. And one more? Yep.
0, negative 6.
0, negative 6. Yeah. Remember, your circle means that the radius is the same length from your center. Use your imagination. It's it's supposed to be a nice even circle. Okay, so that means this right here, this length right here is 6, this here is 6, this here is 6, this here is 6, this diagonal line right here is also 6. Okay, so to write the equation, since it's at the center 0, 0, it's just x squared plus y squared equals my r, which stands for radius, so 6 squared. Okay. And the only thing we can solve in this equation is to simply square this. So our equation is x squared plus y squared equals 36, and that's it. Okay. So similarly, if I give you backwards and say x squared plus y squared equals 81. If I give you this equation, what is my radius then? Arian? 9. Because it's square root 81, which gives you 9. Okay. Yep.
What do x1?
I'll show in the second example. It will answer your questions. Yes. So good question. You're asking ahead. Okay, but we'll get to your question. All right. So determine if the point 2, 5 is inside the circle or outside the circle. So 2, 5 is right here. It looks pretty close. Is this actually on the outside or inside? Can I tell by just from the graph? No. How do I check it mathematically? Right. So this is my circle formula, which we found right here. I'm going to plug in the x and the y value. So 2 squared plus 5 squared. So on the left side. 36 is on the right side. 2 squared, 4. 5 squared, 25. So when you evaluate it, you get 29. 29, is it, it's less than 36. When it's less than, that means it is inside the circle. So that point right there is actually inside. Okay. What if I get something and it was 36 equal 36? What do you think that will mean? Pratik?
It's on the line of the circle.
It's on the circle. Yeah. And what if it is, like for example, 37? So it's greater. Yep, good job. So if it's when you plug in the points and you evaluate it and it's greater, then that means it is outside of the circle. Outside the circle. So the x and y, it represents the so Ryan, the x and y represents the points on the circle. And then so when I give you any point, you would have to plug it into the x and y to see if it's inside, outside, or on that. Okay. Do you need to notice? Yes. So when I mark the test, this is the part where I can tell who's been paying attention in class. Because it's not hard to understand. This part is not hard to understand. But if those who didn't get the question on the test, they weren't paying attention. And there's no trick to it. Like that's all I'm going to ask you on the test. Okay. Last example, because this is such a short lesson. Hey. Identify the center and radius of the equation and then sketch the graph. Okay, so what is the difference between this equation and the one that we were working on? Right. The original equation was x squared plus y squared equals r squared. But now notice there's a bracket part. That means it's not at the origin. So this is at center at center 0 0, and this one it means that it's at center. Who knows what our center is right here? Okay. Minus 5 3. Very close. Hit it. 5 negative 3. So how you can think of it is there's actually a x minus what letter did I use for did I use HK? Let me see. Let me check really quickly. Equation of a circle. HK, yeah. Okay. Okay. So when it's not at the center, when it's not at the origin, this is the equation of a circle. So and notice the standard form of this equation. They use the minus at center HK. So in other words, because it's minus, your H, when you compare it, your H is 5, positive 5. And your K here, in order to make the equation from a negative to a positive, that means your Y value of your center is negative 3. Okay. So 2 formulas you have to memorize for this lesson. This one, when it's at 0 0. And this one, when it's not at 0 0. Okay, so we can plot this 5 negative 3. So 5 negative 3 right here. That's our center. So radius. What's our radius here? Yeah.
4.
4. Good. Just like right here. Same r. The r didn't change. R is going to be square root 16 in this case, which is 4. So I can go do 4 on this side. 1, 2, 3, 4. 4 on this side. 1, 2, 3, 4. 4 up this side. 1, 2, 3, 4. 4. 1, 2, 3, 4. Can I go like this and do 1, 2, 3, 4? 1, 2, 3, 4 like that? No. All right. Remember, just like in a triangle, your diagonal, your hypotenuse is always longer. So it's not diagonally. You can only do the radius up, down, left, and right. And then it should be enough for you to draw the circle. Okay. So far, so good?
Wait, so the formula to find H and K, yes. So because they subtract, they flip one.
Yep. Okay. And later on, when we do parabolas, it's the same thing. Okay. Last example. The diameter of a circle has endpoints this and this. Find the equation of the circle. Okay. So let's do a quick little sketch first. The diameter of a circle has endpoint 18, negative 13. 18, negative 13, so somewhere down here. 18, negative 13. And the other one is at 4, negative 3. 4, negative 3. So like something like this. 4, negative 3. So and then that's the diameter. That means my circle looks something like this. Okay. So in order to find the equation of a circle, what do we need? Yep. I need to know the radius and I need to know the center. Good. Okay. So using what we've learned in this chapter, how do I find the center? Okay, Kelly? Yeah. Midpoint. Since these are my two endpoints, that means if I do the midpoint, I can find the center of my circle. So midpoint formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2. So let's call this x1, y1, x2, y2. So 18 plus 4 divided by 2, negative 13 plus negative 3 divided by 2. 22 divided by 2, 11. Negative 16 divided by 2, negative 8. And there we go. That's our center. Oops, sorry. Okay, so next thing I need to find, so we found the center. Woohoo. The next thing we have to find, radius. What did we learn on Friday that allows us to find the radius? Yep, Samantha? Distance formula. That's right. So I know this point, which is 11, negative 8. I'm going to use the distance formula to find the length of this. Remember, radius is just the length from your center to an endpoint. So distance formula, x2 minus x1 square plus y2 minus y1 square. So don't forget I'm using these 2 points right now to find my radius. So x2, 18 minus x1, 11 plus y2, negative 13 minus y1, which is negative 8. Okay, 18 minus 11, 7. So I have 7 square plus negative 13 plus 8 is negative 5. Negative 5 square. So square root it, 49 plus 25. 49 plus 25, square root 74. Okay. Should I change it to a decimal right here? Max?
No, because like in the formula, it's just going to turn backwards to the
Good job. Excellent. So I never answered the question yet. Okay, we found the radius, we found the center, but we have to put it all together to find the equation now. So the equation was x minus h squared plus y minus k squared equals r squared, right? So now we're going to sub in all this. This is my h, this is my k, this is my r. So x minus 11 squared plus y, what do I put here? What do I put here, Kelly? Plus 8. Right? Just like what Ryan was saying, because this is minus and this is minus, it becomes a plus, equals root 74 squared. And what's root 74 squared? It's just 74. That's right. So that's why we don't need to change it to a decimal, because when you square a square root, it just basically cancels out. And that's the equation of this circle right here. Okay. So there you go. Okay, so that's the lesson. 16 minutes for the rest of the class. I want you guys to try these questions and the questions on the second page. So this first page right here, these are questions based on where the center is at 0, 0. And then the question on the second page is where the center is not at 0, 0. Okay. On the test, you'll see both. You'll see where it's 0 at the origin and not at the origin. Let me just show the homework. So content, analytic geometry, chapter 2, and then 2.4, equations of a circle. So when you scroll down, you'll see the questions. Okay, so these ones right here, 1, 2, 4, and 6 on this page, and then the 6 questions on this page. Okay, and then the answers are given. And then tomorrow we'll work on the chapter 2 review. If you want, after working on the review tomorrow, or if you're ahead, you want a challenge, you can do the second review right here. But this is a challenge review. So questions you find in this chapter 2 review 2 is going to be harder than the questions you see on the test. But so tomorrow we'll just focus on this. Yeah. Maybe at the end of the day I might update it. Otherwise tomorrow the latest. Hi.